Hello and welcome to this Python activity. In this activity, we will be working with the Pandas Python library. We will use Pandas to read in a CSV of Pokemon data into a data frame. We will then remove any unnecessary columns, group by Pokemon type, and find the average values for each type. Finally, we will get the total power level of each Pokemon type by summing all of the other stats together and creating a new column called total power. As a bonus, we will sort the data frame by total power and save it to a CSV. We will start by opening the starter notebook. Here, we have some pseudocode for what needs to be done in each cell. As always, we will import our dependencies at the top of our code. For this activity, we will need the Pandas and NumPy libraries. Next, we will be creating the path to the Pokemon CSV file. In our case, it is located in the Resources folder with a file name of pokemon.csv. This is saved to a variable called PokemonCSV. We will then use our Pandas library to call the readCSV method. This method takes in a single argument as the path to the CSV we wish to open. This will be the PokemonCSV variable we created above. Once Pandas reads the CSV, it creates a data frame and saves it to the variable PokemonPD. Let's then print out the first 5 rows of the data frame by using the head method. Here we can see all of the columns in our data frame, as well as the stats for each of the first 5 Pokemon. However, we don't need all of these columns to do our calculations, so we will need to remove some of them. We can select the columns we want in our data frame by calling the original data frame PokemonPD, opening a set of square brackets, and then inside those square brackets we pass a list of the column names that we wish to keep. For our purposes, we want to keep the columns Type 1, HP, Attack, Defense, Special Attack, Special Defense, and Speed. This will generate a new data frame that will be saved to the variable Pokemon type. Let's again check out our new data frame by calling head on the Pokemon type variable. This will print out the first 5 rows, and we can see that we now only have the columns we selected from the original data frame. Now that we have the data we need, we can start the process to determine which Pokemon type is the most powerful. Our first step to finding the most powerful Pokemon type is to get the average stats for each type. Pandas allows us to do this quite easily with the GroupBy method. We call the data frame we created above Pokemon type and use the GroupBy method. This method takes in a list of column names that we wish to group by. You can group by multiple columns, but in our case, we just wish to group by type 1. After we determine which column we want to group by, we then need to decide what type of aggregation we want to perform. We will be using mean to get the average stats for each type. This is saved to a variable called Pokemon comparison. On the back end, this is finding each Pokemon of a certain type, summing up their stats, and dividing by the number of Pokemon in each type. This new group data frame will display the type name as the index and have each column as the average stat for that type. We can see this by outputting the entire data frame by putting the Pokemon comparison variable at the end of the cell. After running the cell, we can see that we have each Pokemon type as the index, and the following stats are the averages for the corresponding type. Our next step is to get the total power for each type. We do this by summing all of the other stats together. We will want a new column to place the total into. This is done by first calling the data frame variable Pokemon comparison, opening up a set of square brackets, and then giving a string value of what we want the name of the new column to be. We will name it total. We then set this column to the sum of all the other columns. You could get the sum by calling each individual column and adding them together using the plus sign, but there must be an easier way. Pandas makes our life easy by giving us a handy method called sum. Sum is used by calling the data frame we wish to sum. In our case, this is Pokemon comparison. We then call the sum method with a single parameter, axis. Axis defines where we want the function to be applied. There are 2 options, 0 for the index and 1 for the columns. We will set it to 1 since we wish to sum up the columns to get our total. We will again output the entire data frame by calling Pokemon comparison at the end of our cell. We can now confirm that we have successfully created the total column, and it is in fact the sum of all the other columns for the given row. The final step to find the strongest Pokemon type is to sort the data frame by the total column. This will put the strongest type at the top of the data frame. We create a variable called strongest Pokemon and will set it equal to the sorted data frame. We sort the data frame by first calling the data frame Pokemon comparison and using the sort values method. This method will take two arguments. The first is a list of the columns you wish to sort by. We will just be sorting by the total column. The second is ascending equals false. The default is set to true, which would put the weakest Pokemon type at the top, but we want it to sort in descending order to get the strongest at the top. For the final time, we will output the data frame by calling the data frame variable at the end of our cell and running it. We can see that Dragon-type Pokemon are the strongest on average, followed by Steel and Flying. The next step is to then save our sorted data frame to a CSV. This is done by calling the toCSV method on the data frame variable. This will take in two arguments. One will be the path to where we wish to save the CSV. We will save it to a folder named Output and to a file called PokemonRankings.csv. Note that you will need to have the output folder already created in order to save it there. The other is Index, which is set to either true or false. We will set it to true since we wish to include the Pokemon types in the CSV. We can now open our newly created CSV and confirm that all of our stats are there. That completes this Python activity. Thank you for watching.